Can you solve this exponential equation? As a pre-calculus teacher for 10 years now, I occasionally run into problems that even I will have to think about because of their rigor, and this is one of these problems. Here in this exercise set, 25 through 38, solve each equation by the method of your choice, support each solution by a second method. And here we have problem 25, which is the first problem in this set, which is a simple logarithmic equation. And my recommendation to my students is the ones that you can solve algebraically, see if you can do them, but then as a fallback, any that you cannot solve algebraically, you can go ahead and solve them by graphing. And so we plow through this exercise set. Problems 25 through 28 are problems of this nature, but then we get into the next portion, one of which is problem 31, which is an exponential equation that isn't as easy to solve, and even I, as experienced as I am, have to think about this. And so I'm going to work this particular problem 31 out algebraically, and then I'm going to support graphically later on. What I notice, first of all, we have e to the x and plus e to the negative x, and I recognize, because of my experience, that this is going to end up as some sort of a quadratic form to be able to solve. And so let's go about solving this equation. What I'm going to do is I'm going to eliminate what's in the clear denominator by multiplying both sides of this equation by 2. And when we do that, we have e to the x plus e to the negative x is equal to 8. Now, what I'm going to do is multiply. We're going to get rid of this e to the negative x by multiplying this whole equation by e to the x. And it's my experience which makes me do this. But what we have is when we multiply the left side of the equation by e to the x, we get e to the 2x, and then we have e to the negative x plus times e to the x is going to be e to the 0 power. I hope you recognize what that is. And that's going to be on the right side 8 e to the x. And then e to the 0 power is 1, so I'm going to rewrite this with 1. So we have e to the 2x plus 1. And I'm going to subtract 8e to the x from the right side, so I'm going to bring this over as minus 8e to the x. And then we have 0 remaining on the right side. Now, I don't know if it looks like this to you, but this is a quadratic form already, and I'm going to demonstrate that shortly. What I'm going to do is make a substitution for e to the x, and that's going to be this: let e to the x equal some unknown or variable we'll call w. And so we're going to rewrite this as what we have is e to the 2x becomes w squared, and I'm going to have minus 8 e to the x is going to be minus 8w, and we have plus 1 is equal to 0. And so now we have laid bare this quadratic form. And this is a quadratic form that is not factorable, because you cannot get two numbers which when multiplied together equal 1, that when added together equal negative 8. And so for this we're going to use the quadratic formula, which is w equals negative b, and b in this case is negative 8. So negative 8 plus or minus square root of b squared, and b is negative 8, minus 4 ac, and a and c are both 1, and this would be over 2a, and a is 1. So what we have here is, I'll bring this up here, what we have here is w is equal to 8 plus or minus negative 8 squared is 64, and then 64 minus 4 is 60, and that's going to be over 2. And I'm just going to do some simplification. 8 divided by 2 is 4, and we have plus or minus. I'm going to rewrite 60 as 4 times 15, and that's going to be over 2. What we can do is take that 4 outside, because outside the radical 4 becomes 2, so we have 2 times square root of 15 over 2. So what we have left is w is equal to 4 plus or minus square root of 15. And now we know that e to the x equals w, which was our original substitution. So we're going to write e to the x equals 4 plus square root of 15, and also we have e to the x equals 4 minus square root of 15. And now we can make of this a logarithmic equation. The base e to the x, we can make that a logarithm, which is log base e, which is natural logarithm of 4 plus square root of 15 is equal to x. I'll put x equals, and also we have x by the same procedure is equal to natural logarithm of 4 minus square root of 15. And then, so we're going to have x is equal to plus or minus, and I will show you here in the calculator I previously worked out. Here we have the decimalized versions, 2 to 3 decimal places. We'll say 2.0634. 2.0634, and of course that's approximately equal to. And then graphically, in the calculator, I solved by graphing, and the way to do this is you set one side of the equation equal to 0. So if I put f of x is equal to e to the x plus e to the negative x over 2, and we solve this equation one side for 0 by subtracting 4. So when we graph this, we should see the same solution set. So we come here, and here is the function entered, and then graphed. We see the x-intercepts here, plus or minus 2.06. I'm going to verify this second trace. 0. This is left bound. This is right bound now. Tap over to the right side of the x-intercept, press enter twice. We get the same thing, 2.0634. So this is our correct answer. I like this problem for one thing, that those of you who are going to my calculus class or another calculus class next year will experience something called U substitution. And so this is kind of an introduction to using substitution to solve. I hope this has been helpful to you. Good luck, and thanks for viewing.